to say first of all that currently our unit is not functional. Obviously there's no wires coming out of it, it's not plugged in. After we had soldered it, we started to get inconsistent results. We thought we had isolated it to an issue with the LCD, but it was beginning to spit garbage out and pulling up old splash screens that were saved on the backpack for the serial design of the parallel LCD that we have, which should not have happened. And we thought that, so there still may be an issue with that, but really what we think has happened is, and this is only within the last few days, we've narrowed it down to this, is the programmer I was using may have been corrupted somehow in the process of our programming, and it may not be transferring the right bits at the right point. We noticed the program was jumping all over the place, and to the point where it just would cease to function at all. It would power up, but it would not do what we had expected it to do. We did, however, have early videos of our functionality, which I'll show you, and this will run through, it's still on a prototyping board, but it's running through dispensing tray 1 and tray 2, so 2 different types of pills, and then notifying the user via the LCD, and at that point it was lighting up an LED to signify an output to our RF. And you can see as Omar removes the cup and it changes on the screen. It's kind of poorly shot. We weren't originally planning on using this, but unfortunately it's the only documentation we have of the functionality other than one other video. And there's also some loud hammering in the background. That's not the sound of our machine. Lights up with Team 2 project. And the pill is dispensing. It's kind of hard to see it moving. You can see this one better. It stops at the right point. It's notifying the user, please take your pills. That's the hammer. Omar is taking the cup. Replace cup when done. He replaces the cup. And then now we were just having it cycle through to demo for ourselves. And it will be the same thing, and you can see the LED was on, and then he took the cup out and it had turned off, which was once again representing the RF. That should be it. We also have a short video demonstrating the pill dispensing, which, if you want to say anything about that, I'm not sure. But it basically shows the switch in action.
Just a close-up view of what the switch is.
And you can see the switch closing and opening, just like that. We had it running on a continuous loop for testing purposes at this point.
That's a lot of pills.
And a Skittle was in there as well. There were Skittles all over the lab.
How did you make your holder out of? Your pill holder?
The actual pill dishes,
These
Yeah,
are,
what did you make that out of?
those are actually purchased. And then whenever you get them, this whole top part is completely sealed. This is actually upside down. And then so I had to cut all those holes out so you have access to putting your pills in. But it's another company that makes pill dispensers.
And so so these are like boxes, pill box type things.
it was, I mean, you could say that. It holds 27 pills, and it was an actual dispenser that would swivel, not automated, really. It was supposed to turn, but it wasn't as robust as this by any means.
Yeah.
And I mean, as you can see, the plastic lid here that he helped cut a hole out to dispense into the tube, so that's why it's inverted with the individual slots cut out for loading, which apparently was quite a hassle from what I understand.
Did it have the gearing in there? Gear on the inside?
Yes, yeah, around the ring.
Yeah.
Which was actually pretty hard to find the nylon gear because looking, most of the time I only found it was like 26 to 30 pitch on a lot of gears. And that one actually takes a 28 pitch, and I can only find it through one company. And so it's kind of an odd size gear. So that took a while to actually get the gear for it. But it worked out nicely because all these, the pegs that the switch actually hits on are lined up. It's a hole and a switch, they're lined up perfectly with it. So we're able to have the feedback to the microcontroller.
So is that PVC for all your
Yes.
tubing there?
Yes.
And how do you have it connected to it or attached?
It's connected under the bottom. It's pretty much just glued on there. Yeah, and then it's just that I think it's an inch, maybe an inch and a half tubing that are connected to the actual pill dispensers, and then it goes into a 2-inch, so a bigger collecting tube that runs down to the front.
And did your keypad work, your interface?
Absolutely.
Yes.
We got everything working. Everything was working till last night.
The funny, yes, we were able to program the time, we were able to dispense on timed intervals, and we were running into an issue where it would dispense one time perfectly, and we'd turn it off to reprogram a new time into it, and it would begin to dispense, and it would kill itself halfway through, jump to a random place of code, and begin streaming data that was incoherent, as if it wasn't linking right in assembly. That's when we began to think that there was something wrong with, I mean, it wasn't a programming issue, it was the way it was loaded onto the chip, or an unstable voltage source. We had many issues with that at first, where, because we have it going from a 12 volt, it comes from the AC outlet to a 12 volt DC, going to another voltage regulator, dropping it to a 5 volt, and we had to mess around with some capacitors trying to stabilize that. We also had to, that's why I went with the crystal oscillator instead of, we were using a different chip to output a clock signal, but that was not stable at all when we had the 2 voltage regulators. Then once we added the oscillator, it really helped a lot. And I really wish we had documentation of the pills. I mean, it's a shame that Eyewitness is all we have. And I think if there was more time, and especially if we could have bought a new programmer to try that out, it would have definitely, I can't say definitely, but I would like to say definitely would have followed through. We did get very close to running out of code space, got down to maybe 2% ROM left, and I was thinking perhaps that could have also been an issue. If you fill up the chip too far, maybe there's an overflow in the stack and it's not handling it correctly. It could have been the compiler. We only used one compiler. I didn't get very far with the MPLAB compiler I mentioned. It was all the micro C. You know, that's how it went.